All right, we're going to continue with our cumulative review. This one we are going to finish the review packet. We're going to do study guide questions number 23 all the way to the last one, which is 29. Okay, so let's start with 23 right here. This is an example where we're just going to go ahead and do the subtraction. We're going to do keep, change, opposite. So we basically just do boom, boom. So we have negative 13, I'm going to rewrite it, plus 27. I see that we're adding a positive with a negative, so what that tells me is we're really going to subtract. And our answer here is going to be positive because the positive has a higher absolute value than the negative does. So I'm going to even write a little plus sign to help remind myself. So here I go, subtract these, get 14. So my answer then is a positive 14. Okay. All right, for this next one, we're doing division, okay, with decimals. So I'm going to go ahead and line it up. Inside, we are going to have our, I'm going to 0.051, and on the outside our divisor is 0.3. Now we know that our divisor must be a whole number, so we're going to basically multiply by 10 on both of them. So this one also has to move over as well. So I'm actually going to rewrite it now. So we have 3 going into 0.51. I dropped this 0 because it's just at the front. So 3 goes into, actually I'll bring my decimal up. 3 goes into 5 one time, goes 2, bring down the 1, that goes 7 times, that terminates right there. So our answer is actually 0.17. No negative signs, that is it. All right, last page, we are on number 25 now. Write an equation for the following and solve. 14 increased by a number is 3 times a number. Okay, so in this case, they're both talking about the same number. We're going to use one variable here, so I'm going to say that a number is represented by x. Okay, I'll do it over here as well. So 14 increased by a number. Increased by means to add. So we're going to do 14 increased by x is, the word is, it means equals. So we're going to is 3 times the number. This problem actually really should say the number, to let you know that it's the same variable. I'll let you know that that is what it's supposed to be. So we're going to go ahead and say now 3 times the number. So it's the same exact number. So here we go. We have an equation that we now have to solve, but this is, I'm going to even box it. This is the answer to the first part. All right, now we have to remember D, C, M, I. D to distribute. There's no distributing here. Combining like terms on single sides. There's no other terms here, and on this side we have 14 and x, which are not like terms, so we cannot combine those. So we are done with both of these. We have to move our variables now onto one side. So I see on this side we have 3x, here we have a single x. So I'm going to go ahead and I'm going to move that over to this side by subtracting 1x here and subtracting 1x here. Okay, so on this side it goes away and we have 14. Over here we have 2x, we can divide by 2, and x is equal to 7. Okay, so there's our final answer, and there's our initial equation. Next. All right, now we have 2/7 divided by 1 3/4. So the first thing I'm going to do is I'm going to change this into an improper fraction, which we're going to multiply 1 times 4 is 4, plus 3 is 7 over 4, being divided from 2/7. Okay, so beware, do not cross-cancel, okay, cross-simplify when we are dividing. Okay, it's only when we are in our multiplication step. So we are going to do the multiplicative inverse, which means to keep, change, flip to change this to multiplication. So this is still 2/7 times, flip this to 4/7. Okay, we can look for cross canceling. There's nothing we can do, so we're just going to multiply across. So the 2 times 4 is 8, and 7 times 7 is 49. Okay, you should check to see if you can simplify here at all, but you cannot. No number will go into 8 and 49 evenly. So this is your final answer. All right, in a problem like this where you're multiplying fractions, remember that we can cross-cancel, and even more so, I think something you might forget is that we can cross-cancel across our 3 fractions, because technically multiplication is commutative, and we can rearrange where we are putting these fractions. So this 4 and this 8 can both be divided by 4, which becomes a 1 and a 2. Let's remember that this whole fraction is negative, so we can include that. This and this can be divided by 7, so that would be a 1, and this would be a 7. And then 15 and 10 can both be divided by 5, so that would make this a 2 and this a 3. So I'm going to go ahead and rewrite this, and let's be extra careful that we include these two negatives in our newly written fraction. So I'm going to write -2. I'm going to write them with my numerator, so it's easier to remember. -2 over 1 times -7 over 3, and then times 2 over 1. Okay, so I don't really see any more cross canceling that I can do, so I'm going to multiply across all three of them on both the numerator and the denominator. So we have -2 times -7, which is a positive 14, times 2, which is 28. On the denominator, all we have is a 1 times 3 times 1, which is a 3. So we just check if we could simplify this. There's no number that goes into 28 and 3 evenly, so this is actually fully simplified. I'll also write down some other acceptable answers. We can also change it to a mixed number. So 3 goes into 28 9 times, because that would be 27. And that means there's 1 left over. So 9 1/3 is also acceptable. All right, for number 28, this is a matter of just using PEMDAS properly, being extra careful because we have multiple sets of parentheses or groupings. So we have multiplication, division, and addition, subtraction together. All right, so looking inside here, the first thing I see is we should do parentheses first. So I'm going to cover that up and say, oh, okay, we have to look inside this grouping first. Now we apply PEMDAS one more time. So when looking through, I still have to do parentheses first. So boop, we go inside once again. Okay, inside this parentheses, there's only one thing that we can do, and that's 30 divided by 6. So I'm going to do that first. 30 divided by 6 is 5. I'm going to keep my parentheses because I have an exponent here. Not completely necessary, but that's how I wrote it, so we'll keep it. Minus 50. You have to be extra careful to remember to write down everything you did not use. Now within these brackets, I see that we have 5 raised to the second power. That's an exponent, so we're going to do that first. 5 to the second power is 25. I can lose these parentheses now. We have 25, sorry, let's write this down. 25 minus 50. Normally 50 minus 25 would be 25, so this must be negative 25, as this number is larger. And our last step is to do the division. 25 divided by 5 is 5, and it is a negative, because negative divided by positive is a negative. So this is our final answer. Thing to be extra careful of is the double set of parentheses and our exponent here. All right, our last problem, here we go, number 29. So it says find the error and then solve correctly. So what I like to do for these problems is kind of cover up what we're working on. I will use a piece of paper and try to think about what I would do personally and then see if it's what they had done on the problem. So that helps to find the error. So we have an equation here. We want to get x by itself. And our variables are on one side, but I see two different constants, one on the left, one on the right. So personally, I'm going to keep my variable here, and I'm going to get rid of this 4. So it's a positive 4. I'm going to subtract 4. Now, I'm already going to take the guess that they might have added 4 because there's a subtraction sign here. So they were thinking the inverse would be to add. But if we add 4 here, that would make an 8, not a 0. So let's check it out and see if that's what they did. And that's exactly what they did. So yeah, 4 plus 4 is equal to 8, not 0, which is what they did here. Okay, so I already found that error. So it's they added 4 to both sides when they really should have subtracted 4 to make this 0. So yeah, let's see if they made another error. 2x, actually here's another error. This negative sign should have been brought down, so that should be negative right there. So that's actually 2 different errors that they made, which then they would be dividing by negative. So okay, let's go ahead and resolve this one and make sure both of those errors are not made. So we have 4 minus 2x equals negative 2. I'm going to draw my line down the side. I'm going to correct that by subtracting 4 to both sides. This goes away. I'm going to bring down the negative this time. Negative 2x is equal to negative 2 minus 4. I think this is a problem from way back at the beginning of the packet. It is actually. Look at negative 2 minus 4. So this is negative 6. You can keep change opposite if you want, and that ends up being negative 6. And now we can divide by negative 2. So x is equal to negative divided by negative is a positive. The answer is a regular 3. All right, so that's how we do that problem. Like I said, there's actually 2 errors there. And that is it for the whole entire study guide.